Good morning, Knights. Welcome back to Chemistry Online. It's good to have you all here. I hope you all had a good Thanksgiving break. Hope you all enjoyed that turkey. Hope you're ready for 3 weeks of school before we go on break again. So this week, next week, and the following week, and then it's Christmas break for 2 weeks, and then you guys are coming back next year. So I wanted to let you guys know something that I recently learned. We are going to be taking an exam that resembles the ACP. I'm not the person writing that exam. It's another teacher at our school. He'll be writing the exam. And what you need to know is you are going to be held accountable for your grades. So I don't want you guys to give up right now. It's still too early. And just to let you guys know, I'll be back next year. So when you guys come back from Christmas break, I'll be here with you guys. And we'll be able to review a little bit before you guys take that exam. That's about it. Let's go ahead and get into what we got to get into. We're going to be talking about, it says here compounds, because we really can't get into nomenclature before talking about compounds. But today's topic is actually nomenclature. Let me write that up here. Nomenclature. T-U-R-E. I think that's right. So everybody write this down. Nomenclature. And basically nomenclature is just the rules that we use to naming compounds. So let's say I write a compound like NaCl or H2O. Here's an easier one. H2O. So when I write H2O, anyone who knows the rules of nomenclature can tell me that this is called dihydrogen oxide or dihydrogen monoxide is what this one would be called. This one right here would be sodium chloride, so pretty easy. You just read the first one, then you read the next one. But there are rules to this, and knowing the rules helps you name these things. Let me give you some more examples. So we also have carbon monoxide. So carbon monoxide means one oxygen after the carbon. And then we have carbon dioxide. Carbon dioxide, that's going to be CO2. So two oxygens that, that's what that 2 is. So there's 2 types of naming. There's ionic nomenclature and then there's covalent nomenclature. These 2 are, actually this one as well. These 3 are covalent. We're not going to talk about covalent today. Covalent ones, they actually require a little bit more work. We're going to talk about them probably starting next week. Today we're going to be talking about ionic nomenclature. Ionic is a little bit easier. That's usually where we start. But before we can talk about naming these things, we have to talk about why they bond the way that they do. So why is it that here we have 2, here we have 1 oxygen, where here we have 2? So understanding those rules is going to make it a lot easier to answer these types of questions in the future. All right, so nomenclature, here it is right here again. That's going to be the rules of naming and writing chemical formulas. All right, so all of these are things, or most of these are things that you should already know. If you want to write them down, go ahead and write them down. If you're new to the class, definitely write them down. So valence electrons, these are going to be the electrons on the outermost shell. So here's an element. And it's got electrons, so that's an electron, but it only has 1 valence electron. The valence electron is going to be the one on the outermost shell. So this one has 1 valence electron, which tells us it's group 1 on the periodic table. So valence electrons are electrons located within the outermost energy shell. Atoms are most stable when they have a full valence shell. So how do you get a full valence shell? You either give away your outermost electron, or you pick up an extra outermost electron, or 2 extra outermost electrons. And once your outermost shell is filled, you're considered stable. And when you're stable, another word for it is going to be neutral. You're not red, you're not blue, you're neutral. All right, next one we have is ion. So atoms that have lost or gained 1 or more electrons. So when an atom gives away an electron, it becomes an ion. Also, when it gains an electron, it becomes an ion. The charge on the ion is known as the oxidation number. That's something we talked about, I think, before we left Thanksgiving, for Thanksgiving. So based on where you are on the periodic table, your charge changes. So if you have one valence electron, you have a +1 charge. If you have 7 valence electrons, you have a -1 charge because you're trying to pick up one valence electron. We'll talk more about it as we move forward. Next thing you need to write, so this one is actually new. This is a new thing. Everyone needs to write this down. So polyatomic ion. That's an ion consisting of 2 or more atoms. So you'll see some of these moving forward, polyatomic ions. But basically they're, well, I'll show them to you in a minute. But they're all on the back of your periodic table, which you'll have when you take these tests. You'll need to know how to identify polyatomic ions. All right, so valence electrons, let's talk about charges real quick. So this is group 1, group 2, and then this is group 13, 14, 15, 16, 17, and 18. So group 18, as you can see, has 8 shells, or 8 electrons in its outermost shell. So this is neutral, it has no charge. But let's come back over to this side. So lithium has 1 valence electron in its outermost shell, and it doesn't want to keep it. It wants to give it away so that it can have it wants to have no valence electrons. It wants to have an outermost shell with full valence electrons. And to do that, it needs to give away an electron. So because it needs to give away an electron, we're going to say it has 1 extra electron. So that's a +1 charge. Beryllium has 2 valence electrons in its outermost shell. So it has 2 options. It could either give away 2 electrons or it could gain 6. Gaining 6 is much more difficult than losing 2. So we're going to give this one a +2 charge. Then we have boron. Boron has 3. It could give away 3 or it could gain 5. It's easier to lose 3, so we're going to call this a +3. But here's where it gets, a little different. So carbon has 4 valence electrons. It can either gain 4 or it can lose 4. And in the case of carbon, we're going to call that plus or minus. So plus or minus 4. Anything in that group has plus or minus 4. All right, next we have nitrogen. So nitrogen has 5. It's easier to gain 3 than it is to lose 5. So we're going to call this one -3. It wants to gain 3, so we're going to call it -3. It's 3 short. Next we have oxygen. Oxygen wants to gain 2, so we're going to call this -2. And then lastly, fluorine has 7. It wants to gain 1, so we're going to call this -1. You need to know these charges for everything we do moving forward. So when we talk about ionic compounds, and we will in a second, ionic compounds are bonds between a metal and a non-metal. And we'll talk about them in a second. All right, so how are ions written? An ion is written as the element symbol with a superscript to the right showing the charge. We're not talking about ions right now. We'll talk about them in a minute. So the sign plus or minus tells us whether the electrons have been gained or lost. So Na +1, it wants to lose 1. So this hasn't lost any yet. O -2, it hasn't changed. So this is, or O2 minus, that means it gained 2 electrons. And then Fe3+, that means it gave away its 3 electrons. And I was wrong about sodium, I'm sorry. So sodium +1 already gave away its electron. That's why it's got a +1 charge. All right, so the number tells us how many electrons have been gained or lost. All right, so let's talk about ionic bonding real quick. So ionic bonding. So first, let's define ionic bonding. An ionic bond is a bond between a metal and a non-metal. So once a metal bonds with a non-metal, we call that an ionic bond. So here are the metals. These are everything that qualifies as a metal. And then here are the nonmetals. These are everything that qualify as a nonmetal. So for an ionic bond to take place, you need a metal bonded with a nonmetal, and that's how you get an ionic bond. And I told you guys we talk about polyatomic ions later. Here are the polyatomic ions. So polyatomic ions are basically, so what makes them ions is they have a charge. So as you can see, everything in this group has minus or a plus charge on it. So everything has a charge, a plus or a minus charge on it. And they contain more than one element. So when elements bond together, they want to become neutral. But in the case of polyatomic ions, they still have a charge. That's why they're called polyatomic ions. They've already bonded, but they're still trying to bond with something else. That's a polyatomic ion. All right, let's move forward. Oh, and polyatomic ions are on the back of your periodic table. All right, so group 1 metals always lose 1 electron. What charge does that give them? It gives them a +1 charge. So everything in group 1 has a +1 charge. Group 17 are the nonmetals. They always gain 1 electron. What charge does that give them? That gives them a -1 charge. So group 1 and group 17, they're ideal for bonding with each other because this one just wants to lose 1. This one just wants to gain 1. So lithium fluoride is something that can happen. Or sodium chloride. Sodium chloride, that's table salt. So that's a very common ionic bond. I can give you more. So lithium chloride, lithium iodide, or rubidium bromide. These things, they always want to bond with each other because they have the same charges. All right, so we're not going to talk about transition metals today. We'll talk about them next week. But basically, transition metals, because we never know what their charge is, the only way to identify their charge is to know what they're bonded with. So let's say we have titanium, and I don't know if this bond is even possible, but let's say we have titanium and then fluoride. So we know fluorine has a -1 charge. If you have 1 titanium bonded with this fluorine, that means this titanium has a +1 charge. But let me give you another example. So let's say we have zirconium, which is in the same group as titanium. All right, so let's say we have zirconium bonded with chlorine. That's going to look like this. So let's say it's going to be ZrBr2. We know that bromine has a -1 charge. We don't know zirconium's yet. But because this zirconium is bonded to 2 bromines, which are each -1, we know that zirconium is going to have a +2 charge. All right, let's move on. So elements that can have more than 1 possible charge must have a Roman numeral to indicate the charge on the individual ion. So let's go back for a second. So what they're talking about there is when you write it out. So let's go ahead and write this out. Let's write out the nomenclature for this. So the way you would write it, it would be zirconium, and then you would need to write the charge after it in Roman numerals. So we're going to put 2. And I told y'all we'll do this next week, but I guess it's included here, so let's just talk about it. So zirconium 2 bromide. And bromide, the IDE, we'll talk about where that comes from in a minute. All right, so elements that can have more than 1 possible charge must have a Roman numeral to indicate the charge on the individual ion. So here they are. So iron with a +3 charge, that's going to be written iron 3 Roman numeral. Iron with a +2 is going to be iron 2. Copper +2 is going to be copper with a 2 Roman numerals. But that's basically it. That's what differentiates the transition metals. And the only way to know the charge on a transition metal is to either look at it written out like this and then see what's put in the parentheses, or to do the math that I just showed you. You have to know what it's bonded with, because what it's bonded to definitely has a known charge. Like the transition metals aren't going to be bonded with each other. All right, so label the chart with oxidation numbers. So let's do this again. So this is going to be +1, +2, +3, plus or minus 4, and then -3, -2, -1, and everything wants to be neutral, like the noble gases where they have a 0 charge. Everything here has an unknown charge. They're all positive. Nothing here is negative. Everything here is positive, but we don't know what the charge is. It could be +1, +2, +3, or even +4. All right, let's go ahead and move forward. All right, so in your notes, you're going to write the ion with the charge for the following elements. So I want everyone to do this practice in your notes. I'll work a few out with you, but then I want you guys to finish out the rest, and you're going to take a picture and submit this at the end of class. All right, so lithium, and you've done this before actually when we did the Lewis, not the Lewis structures. Well, actually, yeah, the Lewis structures. So lithium, that's going to be +1. Beryllium, that's going to be +2. Aluminum, that's going to be +3. Sodium is going to be +1. Fluorine is going to be -1. Chlorine is going to be -1. Iodine is -1. And then just go through, finish the rest of these. All right, so polyatomic ions. Let's get back to them. So polyatomic ions are ions that are made of 2 or more atoms. So an ion is an element that has a plus or minus charge, and a polyatomic ion, that's more than one element that's bonded together that have a plus or minus charge. These atoms can be the same element. So in this case, we have O2, and this O2 has a -2 charge. So this would be considered a polyatomic ion. These atoms may be different elements. So HCO3-, that's an example, and then BO3-3-, that's another example. And polyatomic ions are not as easy to name as monoatomic ions. So luckily for you, you don't have to learn how to name these. The names are always going to be given to you. You just have to look at the chart on the back of your periodic table. Each ion has a name. Some of the names are very similar to each other. So nitrate is going to be NO3-, and then nitrite is going to be NO2-. So you don't have to memorize these, but at some high schools, they are forced to memorize these, and you need to learn them. But in our case, you absolutely do not need to learn them. They're on the back of your periodic table. In college, you're definitely going to be expected to learn these. All right, so again, these are the polyatomic ions. They're on the back of your periodic table. And if you don't have a periodic table, just look at, I posted them for you in Google Classroom. I don't have access to your Google Classroom. I don't know if y'all know this, but I don't have access because I'm on leave. But on the back of the periodic table that's provided to you in Google Classroom, you'll find that the polyatomic ions are on the back of the periodic table. All right, so another thing you need to know is that you cannot split it up when you're writing out the compound. And the charge that you see here is the total charge. So after these things have bonded together, the charge that's remaining on the entire thing is what's written here. So this minus is not only on the H, it's on the OH bonded together. And let me show you where that comes from. So here we have an O, and we know O is a -2. If it's bonded to a single H, we know H is +1. So when this O bonds with this H, you're going to be left with OH-, because this oxygen, it wants to bond to another hydrogen. It wants to create H2O. That's what it wants to be. This is the neutral version. And before it gains that second hydrogen, it's going to have that minus. That's where the minus comes from. In this case, NH4+. So N has +3, and then H has +1. But instead of 3 hydrogens, you have 4. So you have 1 extra hydrogen, and that extra hydrogen is where that +1 comes from. All right, let's go ahead and move on. We're almost finished. All right, so binary compounds. Binary compounds are going to be the first thing we talk about. And all these binary compounds that we're going to be talking about are going to be, binary ionic. So we're going to be talking about binary ionic compounds. Remember, ionic compounds are made up of a metal and a non-metal. And I didn't mention this before, but it could also be a metal and a polyatomic ion. This is the one that confuses people more. Everyone gets metal and non-metal, that's easy. But then metal and polyatomic ion, that's sort of difficult because you don't know the polyatomic ions. You have to have that chart sitting next to you in order to solve the metal and polyatomic ion. All right, so the overall charge of a binary ionic compound is always going to be 0. So binary ionic compounds, their charge will always be 0. So let's work out this example. So sodium has a +1 charge, chlorine has a -1 charge, sorry. And chlorine is going to take 1 electron away from the sodium. Once it takes that electron away, now these two are bonded together, and their total charge is going to be 0, and you don't have to write out 0 charges. So NaCl is going to be written just like that. So this is a binary ionic compound. All right, so when given 2 ions, write the first metal and the non-metal second. So you always write the metal first. So when we're writing these things out, we always write the metal first. And then it wants you to crisscross the charges and make them subscripts. So let's go ahead and work their example. So potassium is in group 1, so it's got a +1 charge. And then oxygen is in group 16, so it has a -2 charge. What it wants you to do is it wants you to take this 2, put it here. So K2, and then the O gets a 1, and you don't have to write the 1. So what you're left with is K2O. So oxygen has a -2 charge, potassium has a +1 charge. Oxygen wants to pick up 2 electrons, so it's going to pick that up from 2 potassiums. And just know that when you're bonding these things together, so when you take an oxygen and you put it with a potassium, you're not only mixing 1 atom of each. Like there's no way to get only 1 atom of each. So when you mix these things together, you're getting millions and millions and millions of atoms. And that's why it's able to bond to 2 so easily. So oxygen has a -2 charge, so it's going to pick up 2 electrons from 2 potassiums, and that's why it's written K2O. So that's how we write out the chemical formulas. And it says do not keep the plus or minus signs, so if it's neutral, you don't need the signs. Signs go away. And reduce the subscripts if possible. So let's say this was, let's say we were dealing with a -2 and a +4. If we had a -2 and a +4, then when you crisscross, there's going to be a 4 here, and you would need to reduce, and that would be KO2. So, but that's not what this is. We'll get to those later on, where you have to do those types of reductions. All right, so write the correct formula for the compounds containing the following ions. So let's go ahead and do some examples together. And it looks like it's already given us the answers, but don't worry about that. So what it would want us to do is just to crisscross. So this gets a 2, this gets a 1, and the way you would write it out, it would be Na2S. Next one, that's going to go here. The minus is going to go here. Well, the minus, we're not moving it. It's just the 1, and the 1 you don't have to write it out. That's going to be written as AlCl3. All right, so again, we're going to crisscross. 3 goes here, 2 goes here. And then that's going to be Mg3 and 2. And a lot of students have problems with the 2 bonding with a 3, but we'll work those out a little bit later on. We'll do more of them later on. All right, that's it. So let's go ahead and move on. All right, so here it says write the chemical formulas for these ions. So let's go ahead and do that. So again, we can just crisscross. So the 2 goes here, 1 goes here, and then you don't write the 1. So that's going to be Na2O. Next one, same thing. So it's going to be CaF2. Next one, crisscross. It's going to be Al2 and then Se3. And the next one, it's going to be Mg. And you could crisscross. You could make this Mg2O2. But then when you reduce, it's just going to be MgO. So this is incorrect. This is correct. All right, next one, K3P. And that's it. So this is how you write out formulas for ionic compounds. All right, last thing we're going to do today, we're going to name these ionic compounds. So that's actually the thing that we really needed to do today. But in order to get to this, we have to do all that stuff that we just did before. So these are the rules to naming ionic compounds. You're going to write all these rules down. These are very important. They're very easy too, but very important, so write them down. So rule number 1, the cation, and we know cation means positive charge, and we remember that because the T looks like a plus. So cation is going to be your metal. Metals always have a positive charge. You always write the metal first. And then the anion, which is the non-metal, that's going to be second. So metals always come first, and then non-metals are second. All right, so 2, it says you're going to name the element. You're going to name the cation. So in this case, our cation is calcium. So you're just going to write calcium. The metal, you're never going to change anything about it. You're always just going to write it as it is. So rule number 2, you're just going to name the metal. So whether it's calcium, lithium, whatever, you're going to name the metal. And then lastly, you're going to name the monoatomic ion. And you're going to take the root of the element, which is basically everything before the last 3. So I and E is, so let's do an example. So chlorine, in this case, we have chlorine, I-N-E. So the root for chlorine is going to be chlor. You're going to take the root and you're going to add an IDE to it. So basically the nonmetals, you're just going to remove the last 3 letters and you're going to put in an IDE. That's how you name ionic compounds. So the root plus IDE. So here in this case, we have calcium and then chlorine. We're going to take the chlorine, we're going to remove the INE, and then we're going to put an IDE, and that's where we get calcium chloride. So fluorine would be the same thing, you change it to fluoride. Bromine would be the same thing, you change it to bromide. Oxygen would be oxide. So each one of these, all you do is you add an IDE to the end, you remove the previous, whatever was previously there. So that's going to be it. I'm going to stop right there. Next class, we're going to move on to some more difficult stuff. We'll do the polyatomic ions then. And that's it. Have a good rest of your day.